Yeah, hello everybody. Welcome to the second day of the Python and AI for algorithmic trading online bootcamp. We have covered already quite a bit of ground, so we have arrived at a admittedly simplified strategy that we have tested also under simplifying assumptions, but we have seen that yeah, it is not too involved, not too difficult once we have the data available, once we have the data pre-processing accomplished to come up with signals based, in our case, on an ordinarily scarce regression-based strategy that we have then translated into signals, and the signals we have used to interpret them as positions. And based on that, we have done our vectorized backtesting, which in the end looked pretty good. But we have also discussed that some assumptions have not been yeah, that close to reality. But I think we can say that this is not too unusual, at least to get started with in the financial domain. We have discussed also traditional finance, and that there are many assumptions that you find in yeah, the most popular and most famous papers and models that might not be really reflecting reality, right? So here in my slide deck, I jump over the introduction. This is what we have covered in the first session on day one. And here, as everybody knows, we have the single link that brings you to all the resources. So not only the code resources, as I write here on the slide, but also links to other pages, to repos, to the slide deck, for example. And of course, also the code resources, plus some other stuff that might be important or helpful for you to later on replicate what we are doing here in the bootcamp, right? In the overview, we have covered day one with the basics, Python, simple strategies, vectorized backtesting. We will add a little bit to our setup. And my goal in this regard, as I was pointing out, is to have something that we can leverage and use yeah, over and over again if there is a need to do so, right? We have gone through a couple of steps back and forth, and have then ended up with an adjusted install.sh script, which we can use to get the basic packages and tools and setups installed and implemented that we might need in the first step, and to which we can add maybe in step 2, 3, or later, to when we discover that there is a package missing, or we want to accomplish something else which requires different tools and different yeah, I don't know, packages, data sets, whatever comes to mind. But overall, the goal is to have this in a replicable fashion. And we will add to our install sh script today as well, so that when we go along, we have yeah, enhanced versions as we move on, right? Today, the focus on day two is on trading platform. This is, if you like, the goal that we have towards the end. The trading platform setup implemented, right? And that we cover, and this is in that sense here it's a bit in a, in a not wrong sequence. I mean, this is not like necessarily sequential, but we will be starting with the AI-based strategies where we're going to use deep neural networks instead of just ordinarily scarce regression, right? We have seen we couldn't go only that far. We have maybe yeah, even only in sample. I mean, in sample is the easy case, right? We have seen that our accuracy ratios have been around 50 point or 51.5, 52 point some percent, right? So this is what we have seen, but all in sample, and we want to attack the same problem, if you like, the same or similar setup with an AI twist where we rely on deep learning instead of the yeah, relatively simple and straightforward, and therefore always a good starting point, OLS-based approach that we have implemented previously. So towards the end of today's day two, we yeah, should have all the elements together, which then allow us to form something, whatever this means, software, scripts, tools, etc., a cloud instance that allows us then to deploy a strategy in the cloud and to let it run in real time and to maybe even watch as the strategy, as the bot goes along and places trades, etc. Right? So that is the plan, that is the overview, and here you see our topics that we have covered. And as a bridge to the first topic, AI-based trading strategies, I want to here go into the AI first finance part. And yeah, the success stories we have covered. So in all the wonderful fields and exciting fields like games, Atari games or board games, right? All these nice stories have helped AI, generally speaking, and deep learning, reinforcement learning more specifically, to quite some popularity. And then recently, I would say this was the, from a public relations point of view, the LLMs in the form of ChatGPT, etc. They finally then took over the discussion. And also, I would say the usage, so the AI-powered tools that now have millions and millions of users on a daily basis. Before, when you speak about TensorFlow or PyTorch, you say, yeah, I'm a programmer, I'm a data scientist, this is what I use, but not the quote-unquote everyday person, right? But the everyday person now is indeed using yeah, platforms like Claude or Gemini or ChatGPT, which is still my currently still my favorite, although here and there I use others as well. Right? So this is the background based on which we can attack our domain, finance, algorithmic trading. We have discussed the physics envy and the beauty myth, right? Where I said, well, there are a couple of standard theories and assumptions that are not reflected in reality. But on the other hand, we have something that is called efficient markets or the random walk hypothesis, which has some good empirical support, right? And which is, from that point of view, not really the best thing for algorithmic traders, right? Because we are up against efficient markets. If markets are really efficient, right, then whatever this means, I'm not defining it here in a specific way, but if they are really efficient, then probably it is hard, maybe even impossible, who knows, to make market superior returns or to generate what is called alpha. Arbitrage pricing, which relates to option pricing, derivatives pricing, hedging, etc., is not in our focus, but efficient markets is something that we need to take into account. Normal distributions, hardly ever seen, and I will add to the story here a little bit with some illustration, so that what I was pointing out verbally only is also supported by numbers and figures, right? That the tails are so important. High peaks and tails are important. It's not that we simply say, yeah, financial market returns are not normally distributed, therefore the mathematics to derive certain results probably is not that simple, right? Because I was pointing out, for example, that using normal distributions generally simplifies things as compared to other distributions that you might consider. But it's not only about that, it has real consequences for different applications, and in particular for algorithmic trading. Therefore, you see, I emphasize this point, and I consider it to be one of the most important ones at all. Right? No linear relationships, usually, therefore, also deep learning methods which can capture nonlinear relationships and highly complex, high-dimensional relationships much better than, for example, ordinary least squares regression. No empirical support, we have discussed this, that's it. And here again, I told you my two favorite charts are coming here with regard to the role of finance and economics as a discipline to predict prices, to do pricing, right, based on predictions, right? We see that more often than not, the professional predictors, the finance professionals, they miserably fail in general with regard to their predictions here with regard to the 10-year US Treasury yield and also with regard to the federal funds rate. So again, we have discussed this at length just as a quick review so that we have the setup fresh in mind when we move on with our other endeavors today, right? So efficient markets we have discussed briefly based on a random walk testing, and I said, well, there is like a little flaw in it by construction, but we then move to returns instead of prices in order to get around that flaw, namely that the lags that we used have been highly correlated. With the returns, we saw that there was basically no correlation whatsoever. And if you would have tested the return series, we would also have seen that that return series in general are stationary, while prices are non-stationary. So two requirements are then met that we have violated before. Data-driven finance, from the printed newspapers to the web-based versions, updated every hour at least, or in real time sometimes, right? To the terminals where you get your real-time information. So I still have the workspace open right here, where you see breaking news prominently with regard to US politics. And there are quite a few of them all around currently, the new president-elect, right? And yeah, we have seen that there's also news streaming in the form of real-time data points, numbers, texts. We have discussed this, right? We have discussed it's not only numbers, it's also text that we are getting. So prices, other data like fundamental data, news, etc. It's simply overwhelming, and therefore even sitting in front of such a real-time terminal often is not enough to crunch all the numbers to get a handle on it. We need APIs, and this is where we are going to today as well. We need APIs to retrieve the data, to then process the data, and in the end also to let the machine do its work. This is not a necessity, not a requirement, but of course, depending on what you want to do, systematic trading, quant trading, algorithmic trading, generally speaking, there is simply no way around. Then also the automated execution here with a 36,000 data points for 15 minutes only, Apple tick data. That's simply too much for a human being to follow along. Also, all the news articles that are streaming in on a real-time basis and the millions and millions of characters that someone would need to read, this simply doesn't work. We need powerful APIs, and this is where we stand, right? AI first finance. So before we get now into it, I have added to the slide deck two quotes. And the first one is one that I really like here by Richard Feynman. It doesn't matter how beautiful your theory is. Think of the beauty myth, right? How beautiful the theory is, capital asset pricing and all these nice theories. It doesn't matter how smart you are. I think we all agree that those people who have received Nobel Prizes over the years and decades, and we've come up with the beautiful and elegant equations, that they have been pretty smart, right? I also pointed out that when you read the original papers, they themselves didn't believe that their models have been a realistic description of reality. And in finance, this might be acceptable to work with such models, but when you think again in terms of physics and engineering, if you want to build an airplane, you rather use physical models or models of the physical world. We can also say that are in agreement with what is going on there, right? Otherwise, probably you didn't want to fly on such an airplane. So if it doesn't agree with experiment, it's wrong. And this, I mean, this is now really an example with regard to the capital asset pricing model that was pointing out, right? It is elegant, it is beautiful, nice, it is still in use. Many believe in it, many apply it on a daily basis, right? But there, in the other paper, we have read that there hasn't been basically any proper empirical support of it over the decades, and still there is not, right? And here, I say, if it doesn't agree with experiment, this is meant by empirical support in our discipline, it's wrong. Yeah, we can say the model is simply wrong, right? It's invalid. And then I want to add another quote, which I want to relate also to the story and, for example, to what was happening to myself yesterday. Namely here, it ain't what you don't know that gets you into trouble. It's what you know for sure that just ain't so, right? The problem is that when you think you know something, like you believe in head and shoulders formation, or you believe in capital asset pricing, you believe in the arbitrage pricing theory, you believe in something, right? This is usually when you get in trouble. With the little coding excursion that we did yesterday, I was pretty sure about starting Jupyter Lab with Jupyter blank lab, which always worked for me over the last decade, I would say. I don't know how long Jupyter Lab is around, maybe not a total decade, right? But it wasn't so, right? And when you think that's simply the case as it is, and it isn't, right, then you get into trouble. If you think there is no traffic jam in the morning and you are sure about that, and you go out and you suddenly face something unexpected, then you might get too late to work, or come late to your lecture at the university, or whatever, right? So that's also something where I would say, when people believe in something, this might often mislead them to a large extent, right? If people say, well, I simply don't know about this particular fact, or how markets behave in these environments, or under these circumstances, etc., this is often a better starting point than to figure out stuff, figure out how it might be working, than to say, yeah, I know how it works, right? I'm convinced that this is mispriced, or I'm convinced about this and that, right? So I think these two quotes, they are like good guides for what we are up to and up against, for example, in the form of efficient markets. In that sense, related to the quote by Richard Feynman, right? This is about, lastly, the what is called scientific method, a method of procedure that has characterized natural science since the 17th century, consisting in systematic observation, measurement, and experiment, and the formulation, testing, and modification of hypotheses, right? And then there's a quote: criticism is the backbone of the scientific method, right? So this is what we should strive for, right? We should do our observations, our measurements and experiments, and then we should stick to our hypothesis, or hypothesis, plural, or we should modify them or reject them outright, right? So this is really something that we should internalize in such a context. And now to the AI first world, right? Machine learning is a scientific method on steroids. It follows the same process of generating, testing, and discarding or refining hypotheses. But while a scientist may spend his or her whole life coming up with and testing a few hundred hypotheses, a machine learning system can do the same in a second. Machine learning automates discovery. It's no surprise then that it's revolutionizing science as much as it's revolutionizing business, and we might add finance, quantitative finance, algorithmic trading, if you like, as well. All right, so we have the machine that helps us in implementing what the scientific method is all about in a much faster, more efficient manner, and where we can say, well, no matter how beautiful our theory, our hypothesis is, it doesn't matter really how smart we are. We need to check whether something is consistent with data, with the outcome, the result of experiments, with analysis, right? After data pre-processing, we analyze the data, we test the hypothesis, and then we need to reject it, modify it, or whatever is necessary. But not that we say, well, I simply believe in something and now move on. I believe that a simple moving average crossover strategy is a good thing to do, and therefore let's do it, right? This is then where we might get into real trouble. And in that sense, when I was saying we are up against efficient markets and algorithmic trading, in 1978, more than 10 years later, after Eugene Fama, a market is efficient here, Jensen writes, with respect to an information set S, think of a large data frame, a large pandas data frame. How many rows, how many columns ever there might be in there, right? Information set S, a fixed one. If it is impossible to make economic profits by trading on the basis of information set S. Right, this is how originally efficient markets have been defined, and this is still used today. In 2004, Timmerman and Granger, that's the guy from Granger Causality, right? In the paper, wonderful paper. You should Google it. It's freely available and download it and read it. I think one of them, from my point of view, one of the most important papers for algorithmic traders. So from a conceptual point of view, it's not talking about strategies. It provides you with a framework, a thinking and working framework, right? The market is efficient with respect to the information set S, and here you see suddenly S of T. Search technologies T of T and forecasting models M of T if it is impossible to make economic profits, right? You see here, it is in line with the original definition by trading on the basis of signals produced from a forecasting model in M of T, defined over predictor variables in the information set ST, and selected using a search technology in T of T. So you see, this is a much more general definition of market efficiency. The first major point I would say that jumps to the eye here is that everything is made dependent on the time variable t. All right, TTT here is all dependent on time t. So we can say that today, lowercase t equals today is something else than a year ago, 2 years ago, 3 years ago, and 4 years ago. And all these relevant sets, S of t, T of t, M of t, they change over time, right? And in that sense, the major takeaway here, I would say, is for us currently, is to say, well, times are changing and markets might be efficient and inefficient depending on the time interval I have a look at it, right? In other words, we might be able to discover market inefficiency, let's say now, today, or yesterday, or the day before, but this inefficiency might last only for a certain period of time, right? This might vanish, let's say, after a month or maybe after 2 years, right? Then such a strategy might not work anymore in terms of generating economic profit. So after transaction costs and everything else, right? That's basically here how we can understand it. And of course, the dimension of technology and model is also included, right? Let's say we got started with OLS regression, which is in use in finance since ages. I don't know when this started, at least in the 50s, I would say, right? OLS ideas, tools, approaches are around since the, I think, 18th century, roughly toward the end of the 18th century. Gauss was already using such methods of least squares calculus, right? So we have now other stuff available, right? We have come a long way from least squares optimization and regression. What we now have available is a completely different set of models and technologies, right? Therefore, we might be able, with the right approach, right technique, right search technology, etc., to come up with something that is still valid in terms of a strategy that generates alpha, so is able to beat the market, right? So there are also the other disciplines beyond just doing predictions, and I have quote unquote made fun of the professional predictors based on the two charts, which I haven't come up with. These are charts from the Wall Street Journal, but again, I really like them because they make the point almost perfectly, I would say. The prediction is a difficult endeavor, right? And here, for example, when it gets to machine learning based asset pricing, you have read here about predictor variables, right? Here defined over predictor variables in the information set S. And this relates also here to predictor variables. And usually think of the capital asset pricing model, you just have one predictor variable, that's the broad market, right? Where you have the beta, which connects the return of a certain asset via its beta based on linear regression, simple linear regression with the market return, and then you have another term for the risk-free interest rate, right? So it's just one variable, but there might be many, many more, right? And when you read through it here, so number of stop level predictive characteristics reported in the literature numbers in the hundreds and macroeconomic predictors of the aggregate market number in the dozens. So, oops, I didn't want to get into that one. In the dozens. Additionally, predictors are often close cousins and highly correlated. Think of our discussion with regard to prices and our approach of OLS regression applied to prices with lags, right? It's a problem when we have here highly correlated features, predictor variables in this context. So traditional prediction methods break down when the predictor count approaches the observation count, or predictors are highly correlated with an emphasis on variable selection and dimension reduction techniques. Machine learning is well suited for such challenging prediction problems by reducing degrees of freedom and condensing redundant variation among predictors. So there are indeed, as it seems, a number of benefits for using machine learning AI-based techniques in the typical financial areas and with regard to the typical problems tackled in finance and economics. And to this end, we might need to add complexity. Like natural language processing, NLP finance might need to go bigger and embrace complexity. So there was always the search, the quest. This is what is meant by the beauty myth and the physics envy, that like E equals mc squared, finance might be governed by such fundamental laws, let's call them, right? Nice compact equations like the capital asset pricing model that describe the world out there in the financial markets, right? But probably this is not the case, right? Here, this article, the unreasonable effectiveness of data is a short one, refers here to the unreasonable effectiveness of mathematics in the natural science, examines why so much of physics can be neatly explained with simple mathematical formulas such as F equals ma, so the force equals mass times acceleration, or E equals mc squared, energy equals mass times the speed of light squared. So here is now the highlighted part. Meanwhile, sciences that involve human beings, and I would say finance involves human beings, although many things happen these days driven by machines and algos, right? Rather than elementary particles, have proven more resistant to elegant mathematics. Economists suffer from physics envy. Here it's where the term is used as well, over the inability to neatly and successfully model human behavior. An informal, incomplete grammar of the English language runs over 1,700 pages. Perhaps when it comes to natural language processing and related fields, we are doomed to complex theories that will never have the elegance of physics equations, right? So the large language models are not based on some brilliant insight and some parsimonious set of rules that the machine learns, right? No, to the contrary, we all know it uses billions and billions of parameters, tokens, right? And it is trained on billions and billions of documents. So it's exactly the opposite, right? LLMs are as good as they are because they get bigger and bigger, and the complexity of the real world is, to a large extent matched by the complexity of the models, by the capacity and the complexity, right? So in that sense here, right? But if that's so, we should stop acting as if our goal is to author extremely elegant theories and instead embrace complexity and make use of the best ally we have, the unreasonable effectiveness of data. So for us, data-driven finance, tons of data, probably not really good to crunch, to leverage the information in the data based on traditional methods such as OLS regression. We might need our AI approaches, deep learning, reinforcement learning, to discover valuable relationships, hopefully. So we have two major elements of finance that drive the application of AI in finance. The one is the ever-increasing volume, variety, and velocity of financial data. So it's simply what we observe in all the other fields. Right? Think again of the 36,000 tick data points as compared to maybe 10, 12,000 end-of-day data points since Apple went public. Nonlinear, high dimensional, and changing relationships. Most of the models assume linearity, low dimension, and stable relationships. It would be nice if this would be the case, but think of the quotes, in particular the one by Richard Feynman. It can be as elegant as it gets. The researcher can be as brilliant as anybody else in the world. If the nice, elegant theory or equation doesn't conform to reality, then it is not of use, right? Fortunately, to what we have already here, to our standard setup, everything that you see here is what we installed already before, right? We can add now the world of the, let's say, AI, machine learning and deep learning, right? With scikit-learn, we have a wonderful package. I will focus rather on Keras today, given our constraints that we have. Keras, of course, in combination with TensorFlow, right? And I go with Keras 2.0, not new version 3, right? So that we have here our deep learning at our fingertips and can leverage, hopefully, stuff that is high dimensional, nonlinear, and where we have a bit more modeling power and flexibility than what OLS regression would allow us, right? So day one, Python, simple strategies, vectorized backtesting. This is what we have covered. Now we enter the world of day two, where we get the foundation with the platform and the strategies that we want to deploy there. Focus, of course, will be on backtesting and there on more realistic backtesting. In particular, I will focus on out of sample performance, right? Out of sample performance. We cannot include everything, so we won't get as realistic as we want to be. I mentioned this in 3 days of relatively short time together. We cannot conquer the whole world that is usually reigned by and dominated by big players with hundreds of people who do this for years on end, right? And full time. But again, I think with regard to a thinking framework, right, and with regard to the basic tools and techniques, we will indeed get from the first ideas to then the deployment in the cloud. That's basically the goal and what we strive for, right? And the question again, yes, of course, everything is recorded. If you have registered on the Quant platform, the recording of yesterday's session is already there. That's a clear thing, right? So let us get back on the shell and let me put on my classes, which makes coding live, writing, typing for me much easier. And here, getting on the shell, I have a bunch of things open here. Let me maybe close certain stuff here that is still running. So, and here, this is on my shell. Here I stick to my Mac OS shell, right? So the Mac OS shell, and here I'm going to run a Docker container. This is for my update. I run the Docker container as I did before. I go with a 999. I think everything should be stopped as of now. I tried another one. This should be the original line that we have there. And I have added, for example, here a JSON file. This is my standard JSON file that I use for the configuration of Jupyter Lab. So I have a number of shortcuts that I typically use or want to have. And this is basically the set of configurations. Like for me, Control-Shift-N is restart and run all, right? Control-Shift-Y is run all above, and Control-Shift-X is run all below. So I'm just highlighting it. If you have your own, or if you say, well, I'm fine with the default, that's good. But when I later on use Jupyter Lab. Again, I want to copy this into the configuration field so that I have my typical shortcuts available. So I've also added here, there is the first Jupyter notebook. Here is the second one, second Jupyter notebook. I have left, so to say, the starting parts with the data that we have used. And here we will, as you have seen already on day one, we will go and add to this Jupyter notebook. And later on, I will push updated versions also here for install sh. I will push them to the gist, right? So let me maybe first update the here the install sh script. All right, so I can do this here on the shell before I get started with a couple of things. I don't know if this will be complete. Vim install by complete, I mean, there might be other stuff that we encounter that might be updated. So what I will need today, for example, is the Git tool, right? This is something that I will need. When I go further down here, I will, you have seen it already in the chart, Jupyter Lab scikit-learn. I want to use pipx inject TensorFlow, but I want to inject it in Jupyter Lab. I also want to have the package pipx inject in Jupyter Lab tf keras. One more that I want to use, pipx inject Jupyter Lab QuantStats. That's also package, a nice package that I want to use to analyze the performance of our strategy. So these are now a couple of additions. You see here, this is the AI part, if you like, scikit-learn. This as well. This is for some backtesting. And later on, when we work with the under the O&A platform, then I install also tpq.io, and I can add this here to the mix as well. So Git up there, screen. Yeah, I think that's a good starting point to which you might want to add later on as well. So speaking of a starting point, I go up here and execute this. I'm now in a fresh, minimized Ubuntu latest image as I was before, and I can move to root live, and with the script just edited, I can bash install and run all of this. I might need, as usual here, to get something into it. Let me down here update that script in the folder. Here we are 8, and this is in 7, right? So it's running through the packages, the Linux packages. Then here you see Python, pipx, installing Jupyter Lab. Just checking here. Here there's a question with regard to in-sample, out-of-sample performance. This is exactly what we are going to tackle in today's session. In-sample is like the easy case, as I like to say. This is like assume you are at university, you are preparing based on historical exam questions for your upcoming exam. And if by chance your upcoming exam only includes questions from previous exams, this can be considered in sample, right? You are probably having a relatively easy time because you have trained on the historical exams and questions, etc. And when you see them again, you might remember, right, what was the answer for the original question. This is then also the question, the answer for the current question. But the problem is, of course, if the professor comes up with difficult new questions that you have never seen before, and this will be then the test for your out of sample performance. And the same holds true for financial data and the markets, right? When I say I'm on the weekend, on a Saturday, and I use, for example, data of the previous week, trading week, let's say, it's all good and nice, right? But on a Monday morning, when I want to start trading, then new data arise that by definition I don't have access to, right? And this is what we want to model and yeah, include there as well, right? So bash, we are good to go. So Jupyter Lab can be started with the original command. What we also have seen, and I want to dive here one step deeper. IPython, for example, is globally not available, and this is based on the handling and the management of pipx or by pipx of the virtual environments. I thought there might be some standard procedure for doing this, but there doesn't seem to be any. But we can do the following. I can check here the list, and you see where the virtual environments are, right? Here, that's the path to the virtual environments, right? And I can create here in this path a symlink to it, right? So that's one thing that we can do in this regard, right? And this would work like ln for the link, ln for the link, and yeah, that's not the right one. Did I check that one? I thought I would have marked here that one. Here we go. So what do we have? Only one Jupyter Lab, and we have not include. There is no IPython, so let me check here. Let me check, because this was like a little bit annoying when I was playing around with it. What we have in Jupyter Lab. Oh yeah, this is in bin. In bin, and in bin we have IPython. Here we go, IPython. So we can use that path here, IPython, and you see that's a pretty long path, and probably nobody wants to type this over and over again. Therefore, now the symlink means symbolic link, and we put this here in that folder, which is basically which we have added to the profile of bash. Now that I have added a symlink here, right, this works, but this is not permanent. Therefore, I have copied this so that I can add this now here from Docker to our install.sh as well, so that we have both Jupyter Lab by default and then also IPython in the global path in there, right? So that was that, and you saw Vim is there. You saw also the folder, what is all in there. But our major thing, and this we can take from here again, how we got started. When the port is the same, here with the dash now in the middle, the port is the same, meaning I start the Docker container with 9999. Here the port must be the same. And also something else which fell into the category, if you something know for sure, I can here simply via Jupyter Lab password set the password. So on Mac, for example, this would be Jupyter server password. Here, Jupyter Lab password. And then you can define a password which gets you around the long token. This not during startup helps you in any way, but if you want to reconnect to the server, then you can do it via a simple password. And that's, of course, think of a cloud instance. You log out, you want to log in again. You rather want to do it with a password and not necessarily with a token, which is, I don't know, 32 characters long, right? So having set the password now, Jupyter Lab allow root, port, IP, and as you can see down here, there is no token whatsoever. When you recall, there was like a pretty long token with numbers, characters, etc., right? Letters. So I can copy now this here, local command, and put it in here. And with the password now set, not with Jupyter server password, but with Jupyter Lab password, as it works here in the new world, so to say, we are good to go. As you know, maybe some others like that as well. I rather go with the dark theme instead of the light one. And now there is time for me to go to the Jupyter.json. This is for the this is for the configuration, and this can be done on the settings editor. And here there is keyboard shortcuts down there. Keyboard shortcut settings editor, keyboard shortcuts, and now JSON settings editor. I need to repeat it. Somehow it doesn't want to recall why that I was already on keyboard shortcuts, and I can simply save now the complete content. So what was in there was just like curly brackets open, curly brackets closed, and I have deleted these two curly brackets and I've added now what is in this file for my shortcuts. So that having said that, we are now in our second Jupyter notebook, and for example, Control-Shift-N. Now here you see Control-Shift-N. Here I can also click Don't Ask Me Again. Restarts and runs all the cells. This is what I use all the time. I can say also Control-Shift-Y, Control-Shift-X, and a few more of these that I have defined. So we have here our starting point, right? We have the data. And what we now want to apply to this data is artificial intelligence. And I mean, this is not really defined. When we say I apply AI to something, AI is not a method, right? Machine learning also is not in and of itself a method. Deep learning, we are closer to a method, right? But what I want to apply is, with the help of Keras TensorFlow, a dense neural network. And now we are on the level where we say, well, oh, suddenly we have a method which we can compare in different dimensions to ordinarily scarce regression, right? So here, this is a weird behavior by Jupyter. Again, it does it. It's strange. Let me do it like this, that it folds sometimes these cells, and I don't know why it sometimes does it. and other times not, right? But before we get into this, I have one more thing for you as a thinking framework or part of the thinking framework, right? I was pointing out that the large returns are important. Here is a Jupyter notebook, and there is a link to this Jupyter notebook, which is HTML form. Here I have it. The importance of large returns. In other words, the tails, right? It's not like what is around zero. No, it's what is on the left-hand side and on the right-hand side, left tail and right tail, right? Here we see that we have relatively high peaks, relatively high, and also tails, right? But here you see it for Apple with regard to the log returns, where I say, well, I have a cutoff at the mean return plus 2 standard deviations and the mean return minus 2 standard deviations, right? And we have from 2,500 observations, we have 45 large positive returns and 72 large negative returns. And these are the important ones, right? We can say that, I mean, it's a little bit arbitrary how I set here the limits, right? The thresholds. It's a little bit arbitrary, but let's say this might be a good way. So let's assume this for the time being, right? Then we have some 120 roughly large returns that are important, right? And you see here now a chart which shows that when we start at 1, and this is now sorted, so the 2,500 plus returns are sorted from the lowest to the highest, meaning from the largest negative return to the highest positive return. And you see that this has this strange shape, so to say, that all the returns in the middle, that they don't make up anything, right? So this is here negligible, all the middle ones, like these are the close to zero ones. Only here, so these are the large negative returns. They bring you almost, they bring your capital almost close to zero, right? And only the really large ones here bring you in this consideration back and on top and on top. So when you look at this for the first time, I also was thinking in front of it for a longer time. It's not that easy to understand, but I think the following analysis is pretty easy to understand. And this is also what you read, for example, in marketing brochures of asset managers that want you to invest in the long term, meaning those that sell you ETFs where they like you to stay in there and don't sell. And their argument is the following: as a long investor, it is pretty bad if you miss out the good days in the markets, right? So here you see, if you are fully invested, this is that chart, fully invested, here you start at a capital of 1 and you end up at 2.7. So that's here with Apple, the passive investor. Let's say you're Warren Buffett. Warren Buffett buys, and now it was in the news that he was selling, diminishing his Apple position, right? And sitting now on 300+ billion of cash. So this was just the news, but overall invested in Coca-Cola and a couple of other companies. Warren Buffett is the typical long-term passive investor, sitting on the sidelines, being convinced of the power and strength of the company and just waiting it out. So this approach would have yielded 2.7, so plus 170% over the course of 10 years. If Warren Buffett would have missed the 5 best days, this number would have gone down to 1.8. If he would have missed the 25 best days in terms of positive return, Warren Buffett and every other long-term passive investor would have lost a couple of percentage points, right? And if you miss out on the 50 best trading days, your capital falls to a level of roughly 50%. So this indicates that it is really important to get the good days, right? This is just the 50 best days out of 2,500. out of 2,500. There you see that all the others, the 2,450, are basically irrelevant when you're not getting here the good performance. But, or here, first the graph, right? Here's the chart, but I think the numbers are clear from my point of view, right? But the story gets quote unquote worse when you say, well, I'm a long investor only and here and there, right? If you are allowed to go short, or if you are at least if you are getting into market timing, let me put it that way, forget what I was saying before. If you are into market timing and you don't do market timing, say you could, but you don't do, then of course you get the 2.7, right? This is like clear, right? Doing nothing. But avoiding the X largest negative return, so avoiding large negative movements. Here you see when you can avoid the 5 largest drops in the Apple stock, 5 out of 2,500, increases your performance to 4.113. If you can avoid the 25 largest decreases in the share price, by whatever means, I'm not saying that's easy and you should strive for it. This is just a calculation for illustration. Then you would have gotten 8.992 here in this context, right? When you avoid the 5 worst days, your performance is 18.679. Impressive, right? Here, the minus 50% are already pretty bad. But on the other hand, if you say, well, I have avoided the 50 worst days in the Apple share price evolution over 10 years. This is like, we can say this is 10 weeks, right? 10 weeks, you're out of the market. Out of 10 years, right? Then your performance is 18, so plus 1,700%. That's tremendous, right? And here you see like this chart, I think says is a bit more meaningful or more impressive, let's say, than the other one, right? This is no market timing whatsoever, and here avoiding the 50 worst ones. So you have the link, you should go through this. It gives you again a little food of thought for algorithmic trading, right? Therefore, we need to get this stuff right. That's the message, right? Now we have a DL-based trading strategy. So I want to replicate the analysis from before, but using a different method, right? To save a bit of time and to not need to go through all of this. Once again, I'm here using the approach from before, or actually I get more. Data pre-processing. So we pick out a symbol. Let us go with the euro US dollar because we have done so before as well. So that we can compare there a little bit, right? Going with 7 legs. We have this typical structure, but here are the prices. This is not what we want. What do we want? We recall, right? We want, like we did it here, the analysis based on, oh, I have already the R calculated, right? Here we have it already. I simply need to change here R. Right? Didn't I? Oh, I have already. I have this. I can stick to what was copied there before so that we have it now as we like it. So R is there, leg 1, and so forth. We have seen this before. We should do as before as well, drop an A in order to not run into any issues here with the not a number values, right? So we have the data available, and now we want to mimic the analysis here. So this admittedly pretty straightforward. We just use now data calls data archont, and then we are good to go, right? That's straightforward, right? we need to do a bit more work here where we want to use TensorFlow, right? So now TF Keras modeling, right? So import tensor, I don't know what exactly, TensorFlow STF from TensorFlow, not TensorBoard, from TensorFlow, import Keras, right? Then what we need is from Keras layers, import input and dense. That might already be enough. From Keras models, import sequential. I like to work with a sequential model, right? So let's see, maybe as usual, we might need something else, and then we go back and import it. So now, again, we want to mimic the OLS regression approach where we have a model that gets fit to the data, and then we backtest it, right? So let's get started with the model. This is the sequential model we get started with. Then model add, we add the input layer, which has the number of lags as the shape, right? So there's one missing, right? The number of lags here, 7 lags. That's the input dimension, not the shape, but the dimension, right? Then we model add dense layer. Let's say we go with 64 hidden units. Activation shall be ReLU, the workhorse, right? And yeah, that's basically it already. Let us duplicate this so that we have a second layer. The same function, we can speak now of a deep neural network. With a single layer, we usually would speak of a shallow neural network, simple neural network. Model add the output layer. The output layer is also dense. And to mimic the OLS regression approach, I get this done as a linear activation so that we do estimation, right? So here for estimation or regression, right? So here we have the hidden layer 1 and hidden layer 2. And here's the input layer. Input layer is the data that is there, right? And then we have the hidden layer. That's the output layer for estimation regression. Last step usually is to compile the model. Compile. We go with the optimizer Adam, standard workhorse, and the loss shall be MSE. Right, let's see. Well, it accepts it. We are already in the game, so a bit more typing, but also a ton more flexibility as compared to simple OLS regression, where there was not that much of wiggling around, right? Just put the dependent variables in, put the output variables in, and then we are good to go. There is not that much more, right? So, but in the meantime, let me briefly check for question. Here, somebody's asking about a list of predictors, right? We have discussed the predictor variables defined on the information set S that we have available. There is, of course, a large set of optional choices that you can go with. Traditional ones like simple moving averages, Bollinger Bands, whatsoever, meaning technical ones, and whatever you can come up with, right? Here in this bootcamp, I'm going to focus on standard stuff that we have here available that is simple. But for example, in a CPF program, we have many instances where we add, let's say, 10, 20 lagged different predictor variables, meaning features, right? Instead of just saying 7 features, we might have then 77 features, to just make an example. There are also in Python packages available for time series features generation, which out of the box can deliver you 200-300 typical time series features from which you then can choose, for example, if you don't want to get them implemented themselves. But I wouldn't say that there is any list where you say, well, if you trade instrument X or instrument Y, these are the typical predictor variables that have proven to be useful. This is, I would say, the secret sauce of everybody who has success in this particular field, right? Yeah, there's another point. I fully agree why there is so many effort being placed on understanding price movements instead of better understanding variables that cause these movements. Yeah, you could say that the signs of causality and causal modeling isn't yet or hasn't yet arrived in the financial domain. Recently, with publications, for example, by Marcos Lopez de Prado, Dr. Marcos Lopez de Prado. He has, for example, published a book, Causal Factor Investing, right? He is now, when you look him up and on YouTube, he is putting forward theories where he tries, or theories and approaches where he tries to really model causality and not only something like correlation, statistical stuff, etc., right? So that's for sure a nice point, and I'm glad that you have put it here on the Discord server so that we can discuss something like this later on as well, right? I would say, is there a specific reason to use MSE? I would say for an estimation problem, MSE is the standard choice here. I would not think that root mean squared error gives us another insight or is better than the MSE here in this context. There might be cases, but I'm not aware of something here in this particular context, right? So we have the model available, and we can already go and do our model fitting, right? Model fit, as we did it before, right? Here we have here data. I can pick it out if you like, just to see the parallel. So pick it out here. Epochs is usually what we would define here. 1, and I can set where both to 1, so true. And it is fitting now, but just in a single step, right? So 709 microseconds per step. And we see the loss. And the loss here is, I would say, not really meaningful. I show you later on why, right? So 1 epoch usually is not what we would strive for. Let's say we go with 100 epochs and set this to 0 so that we don't get messed up here with the all the output, right? So we now have a trained model. I'm not saying that this finally trained or that everything has finished, but there has been some fitting before that we can now leverage, right? You might want to come up with predictions here, like P called, and put in model predict data calls, right? This gives us now a linear output. So we are getting here these values respectively. And just a quick check what we have done with the OLS regression approach as well. Here our prediction, when we plot it in comparison, you see something like before. The basically the amplitude, so the absolute values of the predictions, is well too low. So we might be able to heal this by training the model more. So with the ordinarily scarce regression, this is a one-shot procedure, right? There is a covariance matrix that gets inverted, and here, so there is not, even if you would like to put more effort into it, there is nothing that you can expect to get better. Here we can simply put more effort into it, training it for more epochs. Maybe I should also put a time up front here, and we might be lucky and get better results. And I'm not checking here even the validity of the results or some accuracy. I'm not yet there, right? But we can maybe see some visual impact here. And indeed, we get a visual impact, right? During these periods of high volatility, it gets the amplitude better. This might be simply due to the fact that it tries to minimize the mean squared error. And here you see this for the large deviations, there's a higher penalty than for the smaller deviation. So at least we see one benefit as compared to ordinarily scarce regression. There are many instances where we get higher amplitudes and better predictions. But now getting back to our discussion on day one, the absolute prediction might be nice to have, but usually we would only care, I'm not saying always, but usually we would only care about the direction of the prediction. You recall what we have done in this context, where we have transformed this into the plus ones and minus ones. We say, well, this is just like going up, going down, going long, going short, right? So we can test this here, and I want to use I have installed scikit-learn, you recall, metrics. I want to import accuracy score. I want to do a first check here in this particular context now with our dense neural network. So I write it out, or no, I have it. Yeah, I don't need to write it out. I can simply use NP sign of data R. Right, this is the original data set, and NP sign of data P for the prediction. And we get a 52% accuracy score. So better than our previous first try. As usual, when I present here the 52%, which is the statistical accuracy, think of our discussion here in this context, right? Not every correct prediction has the same value, nor has any wrong prediction the same penalty, right? It is indeed here in this context dependent on which of the returns, right, here we get correctly predicted or not. Therefore, it is a first indicator, right? It's a good thing to see that it's not like, let's say, 40%, but it's also no guarantee whatsoever here for a good result. And speaking of a good result, let us go here to the vectorized backtesting. And I can now, with everything that I've got, I can here go and I copy the caution as well. I have my prediction and I get the sign out of it, meaning position is +1 for long, is -1 for short, right? Here I get the returns of the strategy. I sum them up, and here I get the real world returns. This is just the sum of the log returns. These are the real world cross returns. I mean, I haven't done so before. Usually what we would read in the press, let's say a hedge fund last year has had the wonderful outperformance, the net return of 172%. So this includes my initial capital here, right? And when I do the plotting, you see that this now goes pretty high. We have seen some improvements with regard to the accuracy ratio by doing some more training. Why not doing a little bit more training here, right? Going all over the code again. With deep neural networks, there is no guarantee. There's just a tendency that we might be getting better results there. Sometimes the performance deteriorates. Well, again, this looks, I would say, quite a bit better. It's still, we all agree that's not close to the real return series. The accuracy score has increased a bit. And here the performance has also gotten better, right? So this is the chart when I run. Now you have seen I'm much faster, not going here to the tab. I'm so used to using my shortcut. So this was basically the last slide, evolution with ordinary least squares regression that we have had. This wonderful outperformance already with all the cautionary remarks here in mind, right? And here the number of trades as well, right? I can even copy this here to analyze what the number of trades are in this context. So there are fewer trades taken here, right? That's also a good sign, right? When we get better performance with fewer trades, I would always prefer that, alone from cost perspective, right? This is something that we've gotten here, right? So the strategy can now be, or the hyperparameters, put it that way, can be changed, and therewith, yeah, parts of this strategy. I could go here with more hidden layers. I could use, I don't know, dropout layers, or use some normalization techniques, right? Or use, yeah, you name it, right? There are a number of things that we could do, and many of them, probably not all, are, for example, discussed in my book, AI in Finance, right? When you want to dig deeper into dense neural networks, or also sequence-oriented models such as LSTM, long short-term memory, or even convolutional neural networks, and all the different elements that might play a role in such a modeling context, you can refer to that particular book. But maybe one thing that I want to use here is the following. I want to do some data normalization. I want to introduce normalization, which wasn't that much of a big deal for ordinary least squares regression, but the neural network models, they are known to perform usually better when the data is normalized. So we are dealing here with returns data where we already have stuff around 0, but the standard deviation probably is not really 0, I would say, right? When I have data calls here, the mean value of the different columns, this is all close to 0. No issue with that part, and the standard deviation is all but 1, right? So when we want to go with Z-score normalization or Gaussian normalization, we would like to have this rather on a level of 1 roughly, right? So therefore I would go here with mu, and here with STD, and I do it over the whole data set. This simplifies things a little bit here with setting copies, etc. So data underscore I often use for normalized data sets, where I go with the original data set, I subtract mu and divided by the standard deviation factors. When I now go with data underscore of my columns that I use, and check the mean values, right? They are now, for all numerical purposes, 0, right? And the standard deviation is now 1 throughout, right? So I can now do the same analysis here based on the normalized data. I stick here to the original data for the prediction. Did I no, I haven't started the model again, or defined the model again. It's running for a bit. A bit of work needs to be done here. I think we have done so twice before, for a total of 1100 or something. Here we go. The prediction looks bad, and there's one reason: I need to use the normalized data for the prediction, because this would have been the worst prediction fever curve that we have seen so far. Therefore, I need to go with the normalized one. And like magic, surprisingly, now the predicted values, they look pretty good, actually, pretty close to what we have as the original data. So we are not in a situation where we get tiny improvements here, tiny improvements there, and we see where there's high volatility, that the spikes are higher and the lows are lower, right? This now is not an exact overlap, for sure not. We see whenever we see something blue here, right, then this is not an overlap. But here it's going maybe a little bit too deep, and this looks like here it's almost perfectly getting like these high peaks and down here, right? So with the accuracy score prediction, now we have an 84.489% accuracy. So this was really the kicker. I said before, this was not the only thing that we could have been trying. We could have added another layer, we could have added more hidden units, we could have, I don't know, changed the optimizer here and whatnot. But data normalization, often in this context, is a real kicker. But still, we are all needs to be seen against the background of being in sample and in a very simplified manner. So this is now, of course, going through the roof, right? That's now something. If we could accomplish this, we would be trading for a couple of days and we would be gazillionaires, right? That's completely unrealistic, right? When we have seen something like this, yeah, the market loses 20% and the strategy gains 100% without leverage. I think this is something that people can believe, right? It's not too disastrous or too out of reach, right? But when I show you something like this, everybody agrees this cannot be the case. I mean, this is like magic. You are the god of all markets, and this cannot happen. But that shows the power of deep neural networks in terms of approximation, at least here in our case, in sample. Maybe I go with as one step back to avoid this tremendous overfitting here. I go back and go with, let's say, just 24 hidden units per layer. Go with 100 training epochs. Let's see how good this looks. Yeah, this looks not as good as before. Accuracy is now 54.7. Still, we get a nice outperformance, and even this, I would say, looks to many unbelievable, right? Maybe not impossible, but unbelievable, right? With such a strategy. Of course, we need to take into account that here now the number of trades has almost tripled, but we need to take into account no transaction costs, margins, and all the other stuff, right? Agreed upon, but still, right? That's a big deal, right? Yeah, so one question from the same person. Thanks for being so active. No, normalization of the target column wouldn't be good, because we would then move the targets, how should I say, some positive movement, positive returns would somehow become negative and vice versa, right? We want to keep what we want to predict in the very same way and wouldn't apply normalization to the target variable here in this context. And of course, train test split, this is something that I want to do now with you guys here, that we introduce a train test split, right? Test split rolling here, meaning here this is for time series. They call it cross validation, although it's not really a cross validation. I will show you what we are going to use there, right? So we can go in a very simple manner and say, take 80% of the data and train the model and then test it on the remaining 20% of the data. This is easy to implement, but it is not realistic, right? Because, I mean, 2 years of testing, if you have a model, if you have a machine deep learning model that you've trained on some data, why would you use it in practice for trading over 2 years without updating the model, right? This is nothing that anybody would do. Why should I exclude known information which might be useful, let's say, in the sense of a regime shift, for example? Why would I exclude that, right? Therefore, we would rather go and would have some rolling window and then test the trained model over a short period of time, right? So this is something that I think is quite a bit better, and therefore here, rolling, train test split, cross validation, so all related expressions, and we want to implement this now. In order to do so, I'm going to do it now based on another model. Not really another model, but a model with another approach, right? So here, let's go with the model. And I want to change this now here to sigmoid for classification, right? For actually binary classification, right? And here I want to add metrics accuracy. So what we have done before was estimation, then we applied the sign function in order basically to come to a classification. Here I want to do it directly. And what did I type wrong here? Metrics are going to be a list. Oh yeah, of course, this needs to be a list and not just a string. It's to be a collection. And to this end, I go and add to my data set a directional variable, data R here. And I'm not going now with +1 and -1 because TensorFlow likes zeros and ones much more. So NP where, if this is positive, right, greater than 0, then I put a 1, otherwise I put a 0. So for 0, we would also put a 0. We don't have a special case for 0 here, right? So now I have a directional one. What I'm going to use is now from sklearn model selection import time series split. So, and I want to first illustrate this based on a simple example. I put this down here, excursion time series split so that they see what's going on. So this is the particular function, right? So I've imported it. I just want to illustrate it. Let's say we have a data set, an ND array object, a simple one, NP a range of just 15, for example, right? So I want to split this now into train and test data sets. So this is, of course, simple data, but the logic, what is happening, is hopefully clear there. So my time series split here can be configured. That's the major parameter. Let's say we want to have 3 splits of it, right? And then I show you what it gives me for the train index and test index in TS split. I go with A, print train index, print test index. So what we get is 0, 1, 2, 3, 4, 5, and then 6, 7, 8. 0, 1, 2, 3, 4, 5, 6, 7, 8, and now 9, 10, 11. 0 up until 11, and then 12. So here you see it increases the training data set, right? This is what I was saying before. This was my quote unquote critique. And trust me, you find a ton of examples in my publications, in the training materials, for the very simple approach of taking 80% for training and 20% for testing, right? Here it starts with the first interval that goes for a couple of days. Then the interval for training is prolonged, new data arrives, again, a shorter testing interval, and so forth. So the training interval is increased and the testing interval here stays the same. So this is what this implements, right? We can also, and I like to, this is what I want to do with you guys, right? -1, I do it now with larger numbers, so that we don't need to have a look at the complete output here. -1, so now we, oh, for the test index, no, for the test index, we don't need it. Train test index, no, just go with the complete test index. I don't need it that way. So here I just wanted to have the first element and the last. So first index 0, 5, 0, 8, 0, 11, right? I can set something like the maximum train size to 5, let's say, in my little case here. And you see it's now 1, 5, 4, 8, 7, 11, right? So this is what it does with this particular test train split. I can go, let me now with a larger data set, like 1,000, let's do 10 splits and the maximum train size of 100, and the test size we set to 5, for example, right? So what do we, too many splits? Oh, for 15, yeah, for 15 it's too many, right? But for 1,000 not. So here you see it takes the index value 850 to 949, then 855 to 954, 860 to 940, and it tests it here on this particular one. When I set it to just 1, the test size, it gives me 890, 889, 891, 990. So here it goes now step by step, and that's typical typically what you would do in trading, right? You train it maybe over a fixed or over an increasing time window or index window, if you like, and you test it on a single day only, right? So that you really go over this whole thing like with a yeah, similar training data set and exact same test set, right? So this is the approach that we want to implement here in this context, right? So to this end, now that we have done what we have done down there, I want to do something similar here. No, copied the wrong thing. So let's maybe stick for the time being with exactly what we've got here so that we go step by step. You also see here with the 1000, it doesn't start at the very beginning. So it goes from the back, from the end, index position 999. That's the last index position. And then it fills up the single folds, as they are called, from the back and going then forward, right? If we have enough, we might be getting to the very last one, right? We could have, let's say, also 100 splits here, for example, like here 100 splits. This would also work, right? In this particular case. So, but let us go here with this particular one to get started with. So for our test data set, let's go with for fold, and then we have here the train index, test index. We have seen this before. We go here with enumerate of TS, now split of yeah, we can go with data, right? And we now want to get our X train and X test and not X Y train, the other way around, train and X test and Y test. And given the logic that we have discussed down here for the training data, I would now go data underscore the normalized data ilog. Now I go with the train index. And here, obviously, the labels data and Y and data D for direction. ilog going with the where are we? The again the train index, right? So let me copy this, and here we just replace the test index. This might be short, this might be long, right? So let's see. We now have this rolling element, so multiple training data sets, multiple test data sets, right? And we now need to start basically from scratch, right? Every time I need to create a model. How do I do this? Yeah, here I can define this as a function so that we can easily do it over and over again. Def create model. We just want to get the quote unquote empty model, right? Return model. And here I would say model create model. Haven't executed it before. So, and then we would do model fit based on X train, Y train, epochs would be, let's say, 100, and verbose is false. So that's the fitting procedure. And now we can do the evaluation, right? Let me first show you where we do this just once without being here in the loop, just for the sake of illustration before everything gets lost afterwards. D here. So it does the fitting. This is now obviously over the whole data set, right? This is over the whole data set. We have here model evaluate, right? Where we have the input data and the target data, right? And we can now evaluate the accuracy here. The input data would be in our simple case. Here where we get, right? We get here the mean square error and the accuracy, right? We get here the accuracy, the results, right, are that way. And when I just want to have the accuracy, I can look this up that way. That's the reason why I wanted to show this once, right? Here, the accuracy of that fitting is given by model evaluate X test Y test, and it's the one index value. Here I should go with the index value 1 for the accuracy, right? And we can collect here the accuracies list and collect them here, right? That way. So here, let me go with maybe 500, 2 years, 252, so 504 would be 2 years worth of training data going back, 10 splits, test size 1. And with test size 1, we get only 0 and 1, right? So let's see. Here we go. This is what I was saying. We get only zeros and ones, right? So we can say, well, this was correct, this was incorrect, this was correct, this was incorrect. So this might not be kind of like a good thing to do. Maybe we go, for example, with 1 month worth of trading, right? So maybe 21 trading days per month, so that we get a more meaningful output here for the accuracy given one trained model, right? So changing this, I need to, of course, execute. Oh, this was not. This was just for the sake of illustration. We don't need to execute this. And now we get here meaningful accuracies, right? 50, 47, 57, 38. Yeah, they vary quite a lot, right? I didn't do that much, and they are not trained that intensively, but we get here now something like a time series cross validation, but where we can go over here in our case 10 test splits where we have 504 as the number of training samples and 21 test samples for each such iteration, right? And here we have them collected in our accuracies, and where we then make an array out of it, can easily calculate the mean of it. So it's 44. I would say that's not really great, right? Maybe we need to train it a little bit longer. For example, or need to increase the capacity. I decreased it here, right? But first, let's maybe go with a bit more training. And every time, so this is important, right? For every such test, I recreate the model, right? So it's not that we do 250 and then do again 250 and do again 250, right? We do it here every time from scratch, so to say. Right? And the accuracies now are already a bit higher, at least from what I can tell, given what we have had before. There's a good one, right? Well, should be through shortly. Oh, no, it's not so good anymore. But still, this now ends up out of sample. So for the first time, this is here the average out of sample test performance, right? So the remark here, where is it? Transactional margins, yeah, here throughout is only in sample. So this was all only in sample, and here we see out of sample, it seems to be a bit more demanding, obviously, than just having one data set and doing everything, also the testing on this single data set. That doesn't seem to be a good approach, maybe good from the implementation and the happiness point of view, but not a good approach to then go and pick your strategy here and put it into trading practice, right? We can, of course, now also go and do something like this. Let's go with 1,008, 4 years, 252 times 4 years, and set the test size to 63, like 3 months, or 62, 252, 60 to 40, 64, let's say, right? In this case. So I will let it run now again, but I will then turn the attention after this little excursion here. I will turn the attention to the trading platform, right? When I let it run, this takes a while. When I say a while, I am usually reminded I can also take the time here. Because all this backtesting, we can now go more fancy. There was a question about what are typical predictor variables, right? That we can add, right? And so forth, right? That we can change hyperparameters, we can do a different normalization, we can do X, Y, that, right? But there comes the point where we would say or would like to deploy the strategy on a trading platform, right? And this is the point where we need some API access and so forth and so forth. And to this end, I want to work with Wonder. I think there was a comment already yesterday. They were saying, well, Wonder has no API access. Yeah, Wonder in Europe a while back stopped the API access, which was really disappointing to me. I have a real trading account with them, not only a demo account or whatnot, right? A real trading account. And they simply stopped API support for the accounts without like any notice whatsoever. But the accounts in the UK, and that's where I want to point you to when you go to oanda.co.uk, right? .co.uk, that's important, right? This is where you should go to, right? Not to the European one, you should go here to the UK one. I can also use that directly here. And let me change here the DMD files. So under demo account, go to this particular domain, open a demo account indicating that you are located from the United Kingdom. Then you get a proper demo account which still has API access. And for all our exercises, so to say, I mean, we won't do any real world trading with real money, right? This is absolutely enough, and still I find that it has the best API if it is available. Again, they stole the API access from my real account, which we have used over years, among others, for the AI machine, right? So trust me, I'm really disappointed in this situation. But we can still get the demo account, and for the demo account where know your customer, etc., is not really important. It's just a technical demonstration. I think it's valid to say you are from the UK, you want to test the technology, and you don't want to bet any real money, you don't want to transfer money, you don't want to do real trading, right? So indicate simply that you are from the UK, right? And then you open the account, and the next step or the next steps, and if you want to follow along tomorrow, therefore I'm covering the trading platform today. So here you would go to CFDs and spread betting, right? And then the products, etc. There's join us, try demo, join us. Right here you see the try demo. I wouldn't here simply close it, right? Close it, and then you can go to try demo. I think, yeah, this is a simple demo, right? I think you need to register for a demo application, and then you can use it as well, right? Here on the hub, this is for the management of the UK ones. This all has changed in Europe, right? Their legal structure in Europe and their tech overall, apps and trading platforms, etc., they all have changed, right? So you need to go here and do as if you are a UK customer who want to test the platform and not open an appropriate account. So once you have that, you should then, and I will do so afterwards as well, you should install the TPQ OA wrapper. That's a little Python package from us. Actually, we have implemented and published that, and there you see how this is getting used, can be used. So I want to do the installation here as well. So let me first change this, and here I also add this. We use this wrapper for the V20, that's the name, API, right? That's the package, but I show you how we can install it the way we have gotten along here so far, right? So, but first of all, let me, here you see with my 1063, the number, the average value is just 0.5. Consider all of this as a framework that you should work with and where you should dive quite a bit deeper, right? I think we have put together very important elements on our way, but I wouldn't say that this is by any means finished, right? Again, think of the hundreds of people per hedge fund out there that don't do anything else than working all day on such stuff, and yeah, going through all these different topics there, right? So that's the second Jupyter notebook. Let me put it live. Oh, I cannot do it from here. I forgot about that one, but it doesn't hurt because I need to install this anyway. So here I can do the update. And let me briefly check that you have access now to the latest version under demo account. Right here, there is, oh, I should rather go and provide them empty. So that the gist loads faster here. Yeah, here we have now the DL-based trading strategy, the train test split. We have the model, and here is the, maybe I can add this as well. This was the second one. Here, data pre-processing, Terra's model, vectorized backtesting. That's the model, and here, that's the cross validation. Again, it's not really cross, but this is the time series validation part, right? So now you have access to what we've gotten. In order to proceed, we now need to, and I add this here, Wanda API, right? And what we need to do is to install the package. Once you have the demo account, this is what I expect you to have now. Once you have the demo account, we need the package being installed. And we can install it that way, pipx inject into Jupyter Lab. And now we put in here git plus https. We install it directly from GitHub. The latest version is not available on PyPy, Hillfish, tpqa.git, and this is something that we can add also in our install sh script, right? So let's see, and we have, you recall I've added the installation of git in the beginning to the install sh script, and here that's the major reason, because we need it for this type of installation. So it is now going to the repo, and it has injected TPQ OA into the virtual environment. So I can add this there as well. I haven't used QuantStats yet, but I can show you this also briefly. So this is added, and I can save it. It looks a little bit longer, but it's just referencing here the Git location, right? And once you have installed it, what you need, and this is now important, here you see you need a config file which has this very structure. So you find the account ID in your demo account, you find the access token in your demo account, you need to create it, and then you specify here practice or live, right? So this is what needs to be done, but I think this might be wrong. I think this should be, let me briefly check here. I think this should be a, let me briefly check. No, practice is okay. I thought this might be required to be a string, but it doesn't have to be a string. So when you have this file, I usually call it wanda.cfg, and depending on the location, you can then connect to Wanda here via this little line here. The path needs to be adjusted accordingly, right? So let's see whether it works. Import TPQ OA. It is there, all right? Now TPQ OA .tpq OA, and I have it stored one level up. one level up here, my real CFG file, and I want to call it here API. So the problem is that I'm here in the container. I need to copy this here. I don't want to share it, obviously, because these are my credentials. So I cannot from the Docker container go one level up on my machine, right? So this does not work for security reasons, but let me see. I should be able to here copy. Here I have it. On to live, just for the sake now of the demo. So then I don't need this anymore. It should be here. Here we go. There it is. And I'm connected to the API. And when my first check usually is the get instruments method. This gives us the instruments that are available for trading. And you see there's quite a lengthy list of such instruments, right? Going down here to wheat, West Texas oil, etc. So it's a good sign, I would say. Maybe I just show you here the first 5 so that we don't have that much in there, right? I can also get, like here, shown and illustrated historical data. That's a typical case here to get data for the mid price, let's say. When I copy this in here, I have retrieved the data and get back a data frame here with the date column, open, high, low, close, volume, true, complete, right? I can now go and also plot this. So this all works. Historical data as much as we like. This is obviously from 2022. Let's maybe go 23 to 24, a little bit more recent. Happening the same thing. Data. Let's say we go with the close prices. Plot. Or we can plot here the data. If you want to have this a bit nicer, we just need to execute the first cell, and then it looks as the other charts that we have seen before. I would say much nicer, right? So this is end of day data for euro, US dollar. That's one instrument. So far so good, but if we want to trade, we need to be able to execute trades. So I have open here for my demo account, I have open here the trading app, and you see I have placed already 2 trades here, one on the S&P 500, 1 euro US dollar trade here, right? And by sheer luck, I have made some leverage profit here of 190 euro on a margin of 2833. Right here, you see a couple of different charts open. This is for the S&P 500. This is for euro US dollar, as you can see. And here we have the euro 50 Brent crude oil, BTC. Maybe we place some trade now on BTC. So that's easy enough. We just need to do API create order. Usually when I do event-based backtesting, I call a place order. Create order, what for? Yeah, BTC USD is Brent crude oil, and I only need to define the number of units. Let's say we go with 66, whatever. Right, so this would be a long trade and this would be a short trade. That's very, I would say, simple and intuitive. right? Plus 66 is going long, minus 66 is going short. And in the account, you can also specify the leverage for the account. I think by default it is 30 or 33 or something. So let's say we would want to go short Brent crude oil, right? So we get here the message, default reason going over instrument not tradable. Is it not the right one? BTC market order rejected. Why is it? Maybe it's too large, or maybe the leverage doesn't work. Instrument, did I? It's sorry, it's BTC. It's not BTC is Bitcoin. Sorry. It's BCO, Brent crude oil. BTC is Bitcoin. There is BTC available as well, right? But it's not tradable for the account that I've got there, right? So now I have placed a long order for BCO, Brent crude oil. And you see the message here with all the details. When I go to the overview here, you see now a new trade, 10 long. Here, BCO, price, current. In the beginning, you always have a slight loss due to the bid-ask spread, right? You immediately get a loss because if you like, they get off, or they take the transaction costs off of your investment, right? And yeah, that's the situation now. I have opened 3 trades, and I can, for example, manually here close it or reduce it. Or if I stick to my BCO example, I can go back, API, create order, BCO, no, that's doesn't do it, obviously, BCO, and units. Let's say I go with -5. This means I reduce the order from 10 to 5. You see there's just 5 left. This is easily accomplished. And when I repeat this again, I copy it, repeat this again, it closes out the position, hopefully. Here we go, and the position has gone actually for Brent crude oil. So that's pretty good environment. I told you about the background and how we have been using it, and how sad I am that it's not available for continental Europe anymore, the API. But apart from that, also for real-time streaming, I can show you that as well. Here, API stream data, for example. Let's go with BCO USD, for example, stop after 15 points. You see that we get real-time streaming data also from the API. Here, it's just doing a printout. If you want to do something else with it, this is easily accomplished, right? So 15 data points have been streamed. Real-time data, historical data, order placement, order canceling, order changing, stop loss, whatever. This is all possible with this API. And still, you might notice I'm still convinced by it, and I'm sad, as I was saying, about the lack of this API, the stoppage of the API support for continental Europe. But still, for us, when we want to get started in algorithmic trading, the Onda API that you get access to via demo UK accounts is still a wonderful playground, a wonderful sandbox to get started and stuff implemented, right? Yeah, maybe I start with, or let me add it here to the Algo Bootcamp. So because I had planned for it, and as time is rushing by so quickly, here we introduced vectorized backtesting, right, for our OLS-based trading strategy. And given the simplicity of the approach that we have implemented here, let me get here this in a separate section, the QuantStats module. Why did I install the QuantStats module? Yeah, this is indeed a nice little helper, not helper module. It has its own purpose, but it doesn't do that much. But what it does, I think it does it nicely, right? So that's my take on it. And for backtesting purposes, it is a pretty good thing. So let me execute the whole thing here. And we have just a few values and a single plot here for our backtesting. But since we have the returns data available, we can leverage QuantStats, what I have installed as QS, and do the following. QS, do we have here reports, right? And then we have basic, fuel, HTML, metrics. Let me go with metrics. And when we check it, metrics, we can pass in the returns and define a benchmark. And if we like, we can also define a risk-free rate here, right? Periods per year and a few others. So the first two are the ones that I want to use here, right? And the first one is the strategy return. These are my returns, quote unquote, the returns of the strategy. And for the benchmark, yeah, we have the benchmark returns here, right? And that's basically it already. And it does a few calculations, so less than a second, I would say. Then you see here some metadata. What is the start period, risk-free rate, time in market, 100%, cumulative return, the CAGR, compound annual growth rate, the Sharpe ratio, the probabilistic Sharpe ratio, Sortino ratio, omega, maximum drawdown, longest drawdown days. I don't know where the 3,500 is coming from here. Gain pain ratio, gain pain 1 month, payoff. And you see, without programming a lot of things, right? A lot of things, we get here a ton of useful stuff, right? So I think here, yeah, the drawdown longest, again, I don't know how this is going to benchmark. We don't have 3,500 days there. This is probably a miscalculation because it's basically permanently in a drawdown, right? It starts and loses. So there might be something going wrong with the calculation for this special case, right? And on top of that, this is a pretty long output. On top of that, we can get reports with graphics. So no need to do visualization ourselves. I can go here with reports basic as an alternative, and I'm getting the same matrices here with the same weird result because we don't have that much data points. Here it's complaining about some font thing, but portfolio summary, that's the evolution of the portfolio of our strategy. The Sharpe ratio is reported. Here we see the drawdown visualized, the daily returns, again, with regard to the font. And this is also a nice map here. It's a heat map for the monthly returns, right? Where you can not only year by year do your comparisons, but also checking, for example, whether there are certain months where the strategy performs well. I would say here, for example, in September, but there are other months, right? Here we see dark red and red, or many oranges where it's not that good, right? In January, obviously, it doesn't work that well. February, it's quite a bit better, and so forth, right? That's what you can do. If you want to suppress, and I have figured this out previously, if you want to suppress the font messages here. So I don't know how you feel about this. I don't like these outputs here that don't help me any further. You can disable the Matplotlib font manager, and then, oops, I was jumping over it, and then it simply suppresses the messages with regard to the font, right? There is also a report full, but there is some glitch behind the scenes. So with the current pandas version, there is a glitch, obviously. So it's complaining after it creates here a couple of additional graphics, like end of year returns for single years comparison, right? Distribution of monthly returns, also a nice chart, I would say, right? Then here there is something going wrong with the versions installed. So it's not always that they go line in line, and I didn't want to now downgrade the pandas version just to make the last thing work. But even if we just focus here on, where are we, on the basic report, it's already, I would say, kind of valuable. And you see, no additional work was required. Once we arrive here at the strategy returns, these are the ones that I pass here into the report generation, defining the benchmark, and if I like so, some other parameters, arguments, and that's already it. I think that's easy enough, 2 lines of code to get so many additional insights here, right? Yeah, with that, with this little package that we can use maybe on day 3, tomorrow again. Let me wrap up today's session. I leave it in here. This is already empty. This was updated. Install sh has the SymPy, has the TPQ. So your major task in between day 2 and 3 is to set up a demo account with Wanda, so that you, or O&A, I'm saying since the beginning, Wanda, so that if you like to, that you can follow along, install here the TPQ API package, create this tiny little Wanda config file as described here on the page of the package, right? Should be easy and straightforward. I mean, it's really a small, tiny thing to do. And then we should be good to go and turn our attention on day 3 here to the deployment of the strategy and to see how it hopefully is running in real time and maybe making a little bit of money. Yeah, in that sense, let me finally check here. No questions left over. Yeah, the recordings on the, I mean, you just need to log in on the Quant platform, then you see on the dashboard, you see the recordings. So there shouldn't be any issue in accessing the recordings. The recording of today's session, as usual, will of course also be uploaded and updated. Yeah, in that sense, happy Python and AI for algorithmic trading. Take care. See you for day 3 in the next session. Bye-bye.